Hello friends, welcome to engineering tutorial. In today's video we are going to take forward our discussion on the basic concepts about matrix, and today's concept is about transpose of a matrix. Okay, so let's get started. So suppose we have a matrix, let's say A is equal to A11, 12, A21, A22. This is a matrix. This is a 2 cross 2 second order matrix. The transpose of a matrix is represented by this symbol. Okay, it means transpose of matrix A. The transpose of this matrix, okay, it is obtained by replacing the rows with the column and the column with the rows. It means A transpose can be written as by replacing this row with the column A11, A12, and this becomes the second column. The first row becomes the first column, the second row becomes the second column. We replace the row with the column. This first row became the first column, the second row will become the second column. This is the transpose of a 2 cross 2 matrix. Now, suppose we have let's say a 3 cross 3 matrix A11, A12, 3, A21, 22, 23, 31, 32, A33. This is a 3 cross 3 matrix. Okay, let's say this is matrix A again. So the transpose of this matrix will be the same concept. We will replace this first row with the first column. This first row will become the first column, the second row will become the second column, and this third row will become the third column. So we are basically interchanging the rows and the columns. So it will be A11, 12, 3, 21, 22, 23, A31, 2, 3, 3. Okay. So this is the transpose of a 3 cross 3 matrix. Similarly, if we have a row matrix, okay, consisting of only one row, let's say again matrix A, A11, A12, 13, let's say, means one row and 3 column. The transpose of this matrix will become a column matrix. A11, A12, A13. Okay, so this row becomes column. As there is only one row, we'll get only one column, so it will be a column matrix. One row and one column and 3 rows. So the order of this matrix becomes 3 cross 1. Okay. Now suppose we have these matrices here and we have to determine their transpose. So this is a 2 cross 2 matrix with elements 1, 2, 3, 4. So if we want to determine the transpose matrix, we'll replace this row matrix with the column, the first row with the first column, the second row with the second column. So it will become 1, 2, 3, 4. This is the transpose of this matrix. Similarly here, we'll replace the rows with the columns. So this first row will become the first column, 1, 2, 3. The second row will become the second column, 4, 5, 6. and the third row will become the third column. Now here is the third matrix. So here this is a 2 cross 2 matrix. We got 2 cross 2, as there are these are symmetric matrices. They are square matrices. Number of rows is equal to number of columns. This is a 3 cross 3 square matrix, so this is also a 3 cross 3 matrix. Here this is a 2 cross 3 matrix, 2 rows and 3 columns. So the transpose will be a 3 cross 2 matrix. First row becomes the first column, 1 2 3. Here is in row, here is in column. Second row becomes the second column. So as you can see here, there are 3 rows but 2 columns. The order reversed itself. Okay. Similarly, here also the first row will become the first column, 1 2. Second row, second column. Third row, third column. Here this is a 3 cross 2 matrix, 3 rows 2 columns, which is converted into a 2 cross 3 matrix. Also, so this is how the transpose of a matrix it operates. For a square matrix where the number of rows is equal to the number of columns, the transpose has no effect on the order of the matrix. The order stays the same. But when it is not a square matrix, it is a non-square matrix, the order is reversed. If it is a 2 cross 3 matrix, it will become a 3 cross 2 matrix. If it is a 1 cross 3 matrix, it will become a 3 cross 1 matrix. If it is a 4 cross 5 matrix, the transpose will become a 5 cross 4 matrix. So it will be opposite. Now another interesting property with respect to the transpose of a matrix, which is applicable only for square matrix, is that whenever you determine the transpose of a matrix, the principal diagonal elements will always stay the same. Here the principal diagonal elements are 1 4. In the transpose also, the principal diagonal elements remain the same. They are not interchanged. Here the principal diagonal elements are 1 5 9. Here also the principal diagonal elements are 1 5 and 9. So whenever you calculate the transpose of a matrix, the principal diagonal elements, they stay the same. Okay.